I think the headline challenge of our generation is the Paris Climate Change Accord, which has set the benchmark for CO2 emissions reductions. This is the challenge that the entire industry faces. And it's fair to say not just our industry, but also consumer and industrial. And this is a global challenge that all of us have to meet, including the Oerlikon Group.
Basically, we engineer and process materials and surfaces to enhance and upgrade product functions. And working in close collaboration with our customers in the key markets, we make equipment and tools last longer. We improve the manufacturing of textiles and help conventional cars and airplanes in using less fuel.
Today we coat jet engines, car engines, medical implants, turbine components and so on. These coatings extend the service life of these components, and they also allow them to perform better in whatever environment they're in. That these products are more sustainable in the market because they last longer, and it ultimately means that people need to manufacture less or replace less. This is the key part of the sustainability offering of the Oerlikon Group. We also 3D print parts which weigh less and have a higher performance and use less material in their production.
A couple of years ago, I did a qualification as facility manager. I focused on the question how to optimize heat and power treatment in our facilities. My analysis of our energy consumption here in Remscheid, Germany, showed that a central heat and power system would be a good solution. The principle is very simple. We use an internal combustion engine to drive a generator. The generated kinetic energy is converted into electricity. The waste heat we produce during this process is used for our heating system. As a result, today our CO2 emission is 45% lower compared to a normal German power generator. This is an achievement I am very proud of. Our site in Vadodara in India, we installed solar roof panels in 2018. They produce about 35% of the electricity we need for the site. Our site in Liechtenstein is another milestone on the way to our targets 2030. It is already today 100% CO2 neutral.
Our products coat jet engine components, for example. We coat the turbine blades and the seal segments which run around the edge of the jet engine. This allows the engine to run at higher temperatures, and higher temperatures means more fuel efficiency. So if we go back to 2019, the global aircraft industry saved 25 million tons of CO2 emissions because of our products. That's the equivalent of the CO2 emissions that would have been generated providing energy for 3 million homes for a full year.
Synthetic fibers are everywhere. You wear them on your skin, you feel the softness of the carpets, you benefit from the safety in the tires and the airbags of your car. Today, only synthetic fibers can cover the ever-increasing needs for society, since it requires less energy and resources than natural fibers. Today, the worldwide production is already in the range of 110 to 120 million metric tons in fibers in total, and more than 75 million tons are covered by synthetic fibers. With the introduction of our wings technology in 2007, we have succeeded in taking a decisive step. By reducing process complexity, using highest energy efficient components, and increasing production efficiency to a level beyond 99%, we have been able to cut energy consumption by up to 40% and significantly reduce the waste previously generated. Since the introduction of wings, its product saved a total amount of more than 10 million metric tons of CO2, which is equivalent to the annual consumption of more than 1 million households.
新风鸣集团主要生产2个板块，一个是 PTA， 现在拥有年产500万吨的生产能力；另一个是巨子长丝，一直采用了8马格的维因斯 FDY 和 POY 的生产技术，也是拥有了500万吨的年生产能力。维因斯 FDY 技术呢，在新风鸣呢得到了长足的应用。那么跟上一代的技术相比，电耗呢大概下降了30%。新风鸣因此呢每年可以降低二氧化碳排放大概5万吨。
Well, the rise of electrical vehicles is unstoppable, and EVs will become a key part of the mainstream automotive market. And the electrification of these future mobility concepts is going along with new requirements also for automotive components. EVs have new requirements, and the braking system is a good example because EVs have regenerative braking system. The traditional friction brakes are less used, only 10 to 15%. And in consequence, there's a risk of superficial corrosion on the surface, which reduces the maximum brake power in case of an emergency situation. With our coatings and surface technologies customized for the brake disc, we can protect the surface from corrosion, we can extend the lifetime, we can significantly reduce the fine dust on top of it. We are also developing materials and coatings for future mobility scenarios, supporting alternative drive concepts, connected vehicles and autonomous driving. In this connection, we are already offering new surface technologies for fuel cells and next-generation batteries in order to increase performance and range and to reduce the risk of premature failures. And one good example is our smart coating with some functional sensing elements. So the coating is becoming the embedded sensor, facilitating remote monitoring of temperature, stress and vibrations, for example.
All of our customers' markets are changing. Understanding the external factors which drive the change enable us to form the right research and development programs. It enables us to invest in the right technologies, to be able to mature them in time for when the market demand picks up. We have a team of over 1,000 engineers and scientists who spend their day developing ideas. These ideas help our customers' products last longer in service, either through an improved coating or an improved alloy. The customer themselves can be able to offer a product to someone who drives a car or flies in an aircraft to have a lower carbon footprint.
My dream for a sustainable future is to fundamentally change the way we manufacture and produce fibers in all their facets to make them 100% sustainable and circular for the society.
My dream is to have successful energy management systems, like the one I built here in Germany, at all of our sites around the globe. This is our contribution to our 2030 targets, becoming climate neutral and having an energy management system at all sites.
My sincere hope is that we see a rapid adoption of precision engineered components that are designed purely for functionality, and they can only be manufactured by additive manufacturing. So it's my hope that this technology ramps up dramatically in the next 10 years. This will have a benign impact, a positive impact actually, on most of the people watching this and most of our customers out there in the world.
If you ask me for a really sustainable future, including tackling climate change, reversing nature loss on this planet, this would be on my personal dreaming list. But this is not something any one organization can do alone. So I think now it's really up to all of us to work together for this more sustainable future. And this is also for our children.